session we had discussed about that the client did not have tested the same system they were in the same environment that they were deploying to. But here is the thing, and this is important, the mistake was not about the dev was too simple. Dev is supposed to be simple, right? And dev, it is like the dev is where you build the logic, and not where you validate the reality. The real mistake was not, nothing existed between the dev and the production. No intermediate environment, any intermediate environment was missing there. So no place where the agent could run against the real world complexity before touching the live data. So the first thing I introduced was a proper staging environment, a production sandbox that mirrored the production exactly. The same table count, same naming convention, same schema complexity, same mess. Okay, dev stayed clean and fast for building. Staging, it became the place for truth, validations. Once I ran the original agent in staging without changing a single line of code, it failed immediately. And same failure that had been happening silently in production for 3 days. But now we could see it, and the failure you can see in staging is a learning. A failure the client sees in production is a crisis, right? So what I discovered is that in dev environment, it was having 4 tables. So 4 tables, what you can see this is my PostgreSQL. So here I can say that these are the 4 tables, and here this is into the dev environment. So if I go up, this is about the dev, and another one is about staging. Then here in the staging table you can see some different set of tables where this was like partitioned were there. So here 9 tables are there. I have just replicated that scenario. So I am telling you the 9 tables, that means giving all the partitions. I have not created all the 63 tables because that was their actual real-time system, but I have tried to simulate that case study here. So these are all the tables present in the productions. So you can see in dev it was like the customer, order, customers, orders, transactions, and something like that, even the transaction 2020 2022. But in prod it was like what is that, transactions, then transactions underscore 2022, same transactions underscore 2023, same transactions underscore 2024, then transactions current, okay, that means current year, something like that, and transactions archival. So this is archive. When I say that archive, and this means no need to use this one, right? No, because this is archived. If you want to use some kind of, if you want to run some kind of analytics to know that okay how the transaction was based upon the archive data, you can use this. So all these kind of different partitions were there in the production environment. So now environment was in place and showing us the real failures. The pattern was very clear. Every time a revenue questions came in, the agent was picking up the wrong table. So it was always making a reasonable sounding choice, like it just had no basis for making a correct one. And the reason was straightforward. The context I had given the agent was a raw list of 63 tables in the productions, right? Nothing else. No descriptions, no domain informations, no indication of which table should be considered when, no indication of which table for which year, and what is the usage. All these about the usage guidances, right? And which table will be used for real time reportings. So imagine asking someone to navigate a city and getting lost there. Okay, so I built what I now call a structured data context layer, and every table in the system got four things: the domain tag indicating which business function it belongs to. One thing is that, so when I am saying about the context means the number one is the domain tag. The number one is about the domain tag. What it says about the domain tag, about describing about the business function it belong to. The business function it belonged to. Belong to, right? So what it says, and the second one is about what is that usage, one kind of descriptions about each table, and the third one is that usage guidance. So usage boundary means what it should and should not be used for, in what scenarios. Usage boundary guidelines means in which scenarios a specific table should be used or should not be used, right? And the fourth one is, it is like the some kind of some kind of authority flag. Authority flag means whether it was the primary source of truth for its data type or a derived copy. Whether it's a primary source of truth for, so truth or a derived copy, right? So these four things will consist of the context. When I rebuild the agent context with this layer, okay, when I rebuild the context with these layers, so ran the same revenue query in staging, then the agent went directly to the correct table. And same agent, same code, completely different context, completely different outcome. The agent had not become smarter. It had been given a map instead of a list of just table names, right? So because staging catches system level mistakes, but what about the reasoning level mistakes? Okay, so the one that happens inside the pipeline itself after the context is loaded, when the agent is generating a query that looks correct but is not. Then after rebuilding the context layer and the staging environment, I was not satisfied, because here is the fundamental challenge with the data agent specifically. The output is a SQL query, and the SQL queries execute against live data. If the reasoning that produced the query was wrong, the damage is done the moment it runs, right? Staging catches the failures when you run test scenarios, but in production the agent is running continuously against questions you did not anticipate in combinations you did not test against the data that changes daily, right? So what we have to do, what I needed was something that prevented wrong answers from executing at all inside the pipeline itself every single time without human intervention. So in that case, it's a validator is required. Okay, so that validator should sit between the query generator and the executor. Its only job was to act as a critic. So in the pipeline, validator should be in between the SQL generator and executor, right? So I have already told about text to SQL query, but now if you ask me something more, what does this text to SQL agent does at first? Let's understand. I assume that I had just covered very high level, but I had assumed that okay, you are well aware about text to SQL functionality. So what happens now in text to SQL? It is like user has to provide one kind of natural language query. Natural language query. Give me something like that. And the agent should generate a SQL query. Then it should execute that SQL query on the DB database, and then generates the response, then displays it to the user. So this is the functionality of the text to SQL agent, right? So now what I am saying is that we should have one kind of, because the text SQL query is generated and it is like executing, but there is no validator in between these two phases who has to validate that whether it is correct or not. Okay, so in that case I asked the three questions. So it is like, does the query logic correctly represent the business definition of the metric being? Are there any scope errors, wrong time? So what should be mentioned in this validator? So the first one is that, does the query logic correctly represent the business definition of the metric used, of the metric being requested. Second is one about, okay, are there any means wrong, is there any scope of errors? Is there any scope of errors? For example, like time frame, any kind of filter logic, okay, etc. And the third one is that it is like whether the table selected the authoritative source, the agent selected the authoritative source. That means whether this particular table needs to be used for say that some kind of business definition of metric used. For example, if I give the query that give me the total revenue for 2025, then total is the some kind of business metric, right? And if I give that for 2025, then that is the time frame. Or anything grouped by, if I say that total revenue based on each region, then the filter condition based on the region, okay? And whether this should be considered from the transactions underscore 2025 table or the current table. So that is known as the authoritative source. So when if all the three passed and the query moved to the executor, if any one of these failed, then the query was rejected. The reason was passed back to the query generator as feedback, and the generator tried again with that specific correction. In the first 2 weeks of deployment, then this validation node caught and corrected 11 queries that would have returned wrong answers to the client. Okay, 11 queries, that is not a small number, right? The agent was completely broken. It just needed a critic sitting inside the pipeline. Staging catches the system level mistakes. The validation node catches the reasoning level mistakes. So both are required. Okay. So again we have built the context also inside that one we have given. So these are some kind of mandatory components present in the complete architecture. Okay, so what happened? We came to know about 3 root cause and how we have addressed 3 root cause. First is the staging environment, inclusion of staging environment to validate. Second is that to provide the context, and third is that to validate the SQL query. So what happened today? I want to show the system architecture, how all these 3 are connected, right? So now coming back to the system design session of this production AI agent preventing the convincing failures in text to SQL systems. So this project is about text to SQL demonstration pipeline that converts the natural language business questions into Postgres queries. That's a specific text to SQL objective functionality using a local LLM Llama 3. Then here again I'm using the Llama model because that is the open source. Instead of you can extend that to any proprietary models, OpenAI or Anthropic, something like that. But let's learn with the OpenAI, and that is free of cost also. And then then we need to validate routes and executes those queries against the environment specific database. So now coming how it should be, the complete architecture, how it should be. So when I come this to it is like the system is designed to show how naive text to SQL agents can return some plausible but wrong answers when operating over partitioned production like data, and how architectural safeguards, for example validation, metadata, routing, prevent silent failures. Okay, so AI, the problem, what is the problem statement for this? It is like AI agents do not fail loudly, they fail convincingly. When an LLM generates SQL against partial data sources, the database returns a valid numeric result, and without semantic checks, the agent appears successful while the business answer is incomplete and incorrect. So these are some kind of problem statements, right? And the basic motivation is that it should be the revenue and analytics related questions require querying like the correct authoritative source. For examples like full company revenue must use a unified source, not a single partition. Year specific questions must use the matching yearly partitions. Recent and the current questions must use the real time partitions. So these are the some kinds of authoritative guidelines our architecture has followed. And the system objectives is like that, demonstrate why text to SQL agents fail in production, show differences between dev and staging environment, add some kind of feature flag to show you in absence of the specific staging environment when the user query comes, then in dev how it selects the tables. And after adding this staging environment, that is the exact replica of the production, plus adding the validator, plus adding the context, then how it behaves in an authoritative, retrieving the result from different metadata availability, this context and authoritative sources. So let's start with the complete flow. The flow states that the first is that is the questions user query comes, and that generates some kind of SQL questions. Then it comes with the generate SQL questions, means that will be like Olama model will be used there, and generated SQL will come. After that, in our new architecture, we are having one validator, that is the validate SQL questions it generates. If valid, then it will go directly to the execute query file and it executes the generated SQL query. If no, then there will be some router, and that routes the query to get the information about the metadata, and it generates the corrected query. After the corrected query is generated, then the query gets executed over the our database. We are using the PostgreSQL database. Okay, and then final that the response gets showed to the user. Understand what are the different Python files or the some configuration files or the db.sql files needs to be created, and what is the responsibility of each file, what it does exactly in detail, right? So first is things, any kind of applications we are using Python applications, the agent AI system, the main .py will be like the pipeline orchestrator, right? So here we are having the pipeline. So when I say that pipeline, so it consists of same thing that I had discussed a few minutes back, that is the user query is coming, then generate SQL, then validator. So all these, the complete steps till the final response generation, that is called as pipeline. And main.py is the file that orchestrates this pipeline. So it controls the complete life cycle of a user query, same as I receives the natural query. So next one is about generate SQL. So it is the SQL generation query, SQL generation engine, right? And it converts a natural language questions into SQL using some Olama hosted model that we are using, Llama 3. And the next one is about validator.py. So it is like semantic validation layer. Semantic validation layer, and that examines whether the generated SQL is aligned with the business intent. Then next one is about the router.py, and it is like query correction engine. That means whether the right authoritative is selected or not. Query corrective engine, right? And takes the invalid SQL identified by the validator and redirects to the right authoritative. Then metadata loader. So this metadata, actually we are having metadata access layer where we have to metadata loader .py. Okay, so what happens is it's a metadata access layer and loads the metadata definitions from metadata/tables.ml. We are having GitHub repo structure that I will take you next. Just we are trying to understand what are the different files required here. So next one is about execute PI. It's database execution layer, right? It will execute the SQL query. Then next one is that config.py is the environment and some feature flag. It's the environment plus some kind of feature flag, right? Here I have said that it is config. And demo.py, it is the unsafe demonstration utility. Demo.py, it is the feature flag that is unsafe demonstration utility, right? So besides that, there will be some kind of dev db, and that last time I had showed some development environment for that we should have one database. There we should have 4 tables, and in staging environments also we'll have some tables. And that I will discuss in detail once I take you through the GitHub repo structure and what each file does, that I will discuss there. Now coming back to the system design document itself. Back to our system design specification. So here what is, we have already discussed about the problem statement, business objective, all those. High level architecture about walkthrough of each files also I have given some responsibilities and what each file exactly does. I have explained that one. So next part is that it's a very important thing to understand about how we are simulating the problem, okay, by introducing one kind of feature flag. Okay, so what it does know, if here the unsafe architecture. So let's understand the document itself, then I will take you through the code in a few minutes after this. So when demo mode is equal to unsafe, this demo mode is configured in config.py file. This one, okay. Then we are saying like that it is unsafe, and then in that case it will directly generator. It will go to the generator and then directly execute. It will not go for the validator routing, nothing, right? So and then it will give some kind of wrong answer. But when demo mode is equal to not unsafe, that means only simple something blank, okay, in that case validation will come into the picture. So here same thing, safe architecture, you unsafe or not unsafe, then in that validator metadata routing db and the correct answer is coming. So I have purposefully included this specific flag in our code to demonstrate you in presence of this specific flag that is made that unsafe, how it behaves, and when we added that feature, then how it gets routed to the respective component and the complete each step into the complete pipeline. Okay, so what it does, it validates, gets metadata, router rewrites, routing decisions, right? Component design, each file what it does, that I have already discussed about that things, and through the code again we will go through the code. Now is that the environment design. Yes, the environment selection is controlled by app environment, and that app environment default will be dev, and that will be mentioned inside the config.py. Okay, and there what are the different kind of tables are there, what are the different in staging also, what are the different type of tables are there, it will be there. And we can create some tables here. There are some scripts, dev underscore db. There are some scripts that we can discuss later, how these tables are created and data are inserted. So these are all informations about this. And staging environment, it is a different db itself, text to SQL db, and these are having some partitions, and they are having some kind of sample data also. So next level is coming that metadata layer design. So in this metadata layer design, metadata file location is a metadata tables.ml file. So what is this metadata? When you say a specific information about a table, so what it describes, what is the domain, plus what is the description, plus some kind of column informations, plus some kind of usage boundary. Okay. So it is like in what authoritative source this can be useful. So that will be described inside the tables.ml file, and then we have to load that this specific ML metadata using the metadata loader. So there is a separate file that metadata loader is there, and that will be getting loaded, and then again the execution will be starting. So this is the sample thing. And next is that what are the different attributes: environment, purpose, authoritative, temporal coverage, object type, all those informations are there. How metadata drives behavior. So validation means when the validator.py is coming after generate SQL, next file will be coming validator.py. So it resolves the authoritative revenue source by per environment, detects year specific, flags use the partial partitions, and flags for the real-time sources. So all these informations are already getting captured in the .ml file, that is the metadata.ml file. Once that file is loaded, and it will read, and this once all these metadata informations will get used by validator.py to validate whether the generated SQL query is valid or invalid. Then if the validation fails, then the routing priority is, it should come up the routing. So this router.py will come into the picture. Next, so what it routes, whether the complete the table name, it is taking from the correct partition, and it will verify yearly partition if a year appears in the question specific to, if I say that total revenue for 2025, then it will take me to that transactions underscore 2025. Real time, if it is recent and latest, then whether the that partition is getting used. So all this kind of validation it should do. Source selection is for staging. Dev is for in dev environment the full company revenue is present in transactions, and in staging environment full company revenue is present in transactions underscore view. So when we are testing, when we are putting a specific user query in staging, then always the table should be considered transactions underscore view. So next, partitions can be added by extending the metadata underscore tables.ml file. So query processing workflow that we have already discussed. This is the user, then main, then generator, validator, metadata, execute, and then PostgreSQL. Invalid query also, it is like that is for valid query, invalid query user, main.py, generate, validator, metadata, loader, router, execute, and the PostgreSQL. So what this validator design it does, it is like validation rules implicated. So these are some kind of rules are there: revenue aggregations, year specific source, authoritative full revenue, partial partition misuse, real time misuse. Okay, so whether for all these kind of scenarios the respective table or the views or the aggregations or any kind of filter conditions all are applied or not. So for examples, if I am having one question staging full revenue, what is the total company revenue in staging environment? So it should be always calling that transactions underscore view. Okay, and invalid will be if a specific year is selected, that will be invalid. Okay, and the second is that full revenue, if a real-time source, again invalid. What is the total company revenue? It will be saying that current. No, it will be always transactions underscore view, because that contains the complete data in the production environment for the organizations. And then router design. The router is invoked only when the validation fails. It does not read validator error messages. Instead, it evaluates the validation result active, some kind of active environment. Question semantics, like what are the different, full revenue, year, recent phrases, all those stuff. And based on what the routing rules happens, yearly, any year detected in the questions, then it will be routed to the some kind of temporal coverage present in this tables.ml file. Real times means real phases in questions, whether the real time source, here it will be mentioned. And the environment aware routing examples, total company revenue. What is the total company revenue? Revenue means it is already always in development environment, that is a transactions table, right? We cannot say that orders table. Orders tables is there, but it should not consider that in table. It will be used for by some other use cases, right? And staging, it will be always like transactions underscore view. It will be current is not there. Current means only might be the current year or something, and it will not give the complete picture. Okay, so and here the logging, when routing is applied, the router logs all this kind of routing applied, environment is staging, authoritative source is equal to transaction view, metadata unified revenue